So the equations of the circle C is this. And the equation of a straight line is y equal x minus 3. Good. So we're asked to determine the center and the radius of the circle C. So the circle, let me just put the x's together. So x squared minus 2x. And then we have y squared plus 2y. And let me just keep the positive one here for now. Okay, so we can complete the square. So x minus half of the b value there, which is 1 square, and subtract the square of the b value. So we subtract 1 plus y plus half of the b value there is 1 square, subtract that value, we get 1. So 1 square is 1 plus 1 here, right? Equals 0. So I guess we could note that negative 1 plus 1, that's 0, right? So x minus 1 square plus y plus 1 square is equal to positive 1. So note the center is whatever values of x make the denominator, make the bracket 0. So center is 1 minus 1. And the radius, note here, r squared is equal to 1. So r, so therefore radius r is equal to the square root of 1, which is 1. Remember that this straight line is y equal x minus 3. So show that 1, negative 2 is one of the points of intersection of the circle and the straight line. Show that 1, negative 2 is one of the points of intersection of the circle and the straight line. Let's rewrite the straight line again. The straight line was y equal x minus 3. And the circle was originally x squared plus y squared minus 2x plus y plus 1 is equal to 0. So x squared plus y squared minus 2x plus 2y plus 1 equal to 0. So that was the equation of the circle. And we have to show that 1, negative 2 is one of the points of intersection of the circle, which means that 1, negative 2 should satisfy both equations. So if I substitute 1, negative 2 into the line equation, I'll just substitute 1, negative 2 into y equal x minus 3. The y value, this is x, where the y value is minus 2, x value is 1, 1 minus 3. So 1, negative 2 equal 1 minus 3. So it satisfies the line equation. Let's test if it satisfies the circle equation now. So we substitute 1, negative 2 into the circle. So replace x with 1 and y with minus 2, x with 1, so 1 squared would be 1, plus, if y is minus 2, you square that, you get positive 4, right? And it's minus 2 times 1, that's minus 2. We're using x for 1, y for negative 2. And 2 times minus 2, that's minus 4. Plus 1. Is that equal to 0? Let's check. Yes, 1 plus 4, that's 5. 5 take away 2, that's 3. 3 and 1, 4. 4 take away 4 is 0. So note that 1, negative 2 satisfies both equations. Hence, 1, negative 2 is a point of intersection, right? So we prove that this 1, -2 is one of the places where the circle. So if you have a circle and they say a line cuts that circle, then 1, -2 will be one of the points of intersection, alright? Which we just shown. Determine the equation of the tangent to the circle at the point 1, -2. Okay, so if you have a circle there, and then let's say it cuts 1, -2. Let's say 1, -2 is here. Let's say this is P, where the line cuts the circle. So our tangent is here. Good. So to get my equation of a tangent, the tangent is a straight line. So all straight lines takes the form y equal mx plus c. So our job is to find the gradient and to find the gradient of the line and to find the c value. Now to get the gradient of the line, we need the center. Remember what the center of the circle was? The center of the circle was 1, -2, right? 1, -1, sorry. So the center here was 1, -1. Alright. Now the radius will connect, I'll call this R, the radius of the circle. The radius of the circle will connect the center to the circumference, right? So gradient of radius and gradient is y2 minus y1 upon x2 minus x1, right? So I can call this x1 y1, and I can call this x2 y2. So if I subtract y2 minus y1 will be -1 minus the other y value, right? And x2 minus x1 will be 1. Take away 1. Which tells us something here, which tells us that the line here, so the gradient is undefined here. This would be -1 plus 2, which will be 1 over 0. So notice the gradient is undefined. Alright? So the gradient of this radius is undefined. Which means that the line here, the R value, I guess, so let me just redraw this. Which means the R value here is a vertical line. Since the change in x is 0, it simply means one thing. Alright? So the center, let's draw the center again. Center is 1, -1. More realistic, the radius would be like this. And then this point here is 1, -2. So I sketch 1, -2 would be the point P, and of course the tangent would look like something like that. So the tangent would be a horizontal line, right? This would be the tangent line. Alright, so for tangent line, the gradient will be 0. Notice tangent. Notice the radius line is a vertical line. Alright, we know this because the denominator is 0. It's undefined, which means the x value. And if you plot a graph, notice if you plot a graph point here. 1, 1, where's the point 1, 1? 1, -1. 0. 1 on the x, -1 on the y. 1, -1 is somewhere there, right? And the point 1, -2, I need to go here. The point 1, -2 now would be, so 1 on the x, -1 on the point 1, -2 would be further down. So a vertical line, good? Alright, so the point 1, -2 will, so the point that connects, the line that connects 1, -1 and 1, -2 is a vertical line. Good? The vertical line. So I guess the circle would look something like this. Circle would look something like this. Alright. So the point 1, -2, the tangent would look like this. Notice the tangent here is a flat, so there's no gradient. And of course, this line will certainly cut the x-axis, cut the y-axis, sorry, at -2. So equation of tangent is y equal negative 2. So the best way to get this is to actually do the graph. Get a graph paper, do the actual sketch. Sketch the circle. The circle, remember the circle has a radius 1 and the center 1, negative 1. So it's an easy sketch. So center is here, 1, negative 1, and the radius is 1. Alright, and this of course will be the tangent. So if you do the actual sketch, you will see that the graph, the line here is the line y equal negative 2. That's a tangent line that would touch the circle at least once here. Alright? So y equal negative 2 is our solution. Part B, show that u and v are not parallel. Now, if u and v are parallel, if u and v are parallel vectors, then one is a multiple of the other. In other words, u would be equal to k times v. Alright, where k is some real number. Alright? K is some real number. Now we're told that u is equal to minus 2. Well, u equal to s, sorry. U is equal to S3S. And we are told that V is minus 264. So if we equate, so it's k times, right? Good. So if parallel, S would be equal to negative 2k. 3 would be equal to 6k. And S would be equal to 4k. Now, can S be equal to negative 2k and positive 4k at the same time? Alright, notice notice that negative 2k cannot be equal to positive 4k. Because if you divide both sides, negative 2 is not the same as positive 4. Alright? So it means therefore u is not equal to k times v. Hence, u and v are not parallel. Determine the vector equation of a plane which passes through the point 1, 3, 0 and which is perpendicular to the vector 2, 4, 5. So, the vector equation of a plane is vector equation of a plane. The standard formula we use is Rn equal to An. Of course, where R is x, y, z. That product. N is a normal vector, the vector which is perpendicular, which is 2, 4, 5. Normal or perpendicular vector. A is a point which is 1, 3, 0. And of course, the normal vector we are told is 2, 4, 5. So if we take the dot product of both sides, we end up with 2x plus 4y plus 5z is equal to 1 times 2, which is 2, plus 3 times 4, which is 12, plus 0 times 5, which is 0. So the vector equation of a plane would be 2x plus 4y plus 5z equal to 14. So we are now at question 5, and we are asked to use a u substitution to determine the integral. Alright, so the integral of x plus x to the power of 4 plus 2 all cube 4x to the power of 7 dx. Now we are using u, let me put it over here, we are using u is equal to x to the power of 4 plus 2, so we just differentiate, so du by dx is actually 4x cubed. Differentiate the constant, we get 0, which means that du is equal to 4x cubed times dx. Which means, okay, let us make the substitutions. Alright, so this is the problem we're working now. X to the power of 4 plus 2, we replace that with u, so it's u cubed. And now 4x to the power of 7 dx. Now, based on what we have here, I want to find a substitution for 4x to the power of 7 dx. Now, if you look at what we have here, one thing we can do is to get x to the power of 7, we can times both sides by x to the power of 4. So if I times the left hand side by x to the power of 4, I end up with x to the power of 4 du. And if I times the right hand side by x to the power of 4, and this is at the powers, I left with x to the power of 7 dx. So notice that 4x to the power of 7 dx is x to the power of 4 du. So from here, remember, we don't want any x in the new expression. So x to the power of 4, if you transpose here, x to the power of 4 is actually u minus 2. If you transpose here, subtract 2 from both sides, x to the power of 4 is actually u minus 2. Alright? So this x to the power of 4, we can rewrite as u minus 2 du. And if we expand bracket, let's expand the bracket now. If we expand the bracket, we end up with u to the power of 3 times u, that's u to the power of 4, minus 2u cubed du. Now we can integrate. To integrate, add 1 to the power, divided by the new power, add 1 to the power, divided by the new power, and of course plus our constant. And of course, remember what u was? U was x to the power of 4 plus 2. So we can replace u with x to the power of 4 plus 2 upon 5 minus, well, 2 over 4, that's half, right? So half x to the power of 4. So half, and then u to the power of 4. u to the power of 4. Remember, u was x to the power of 4, right? So replace u with x to the power of 4 plus, well, 1 times that, which is that, right? X to the power of 4. So this is to the power of 5, right? X to the power of 4 plus 2 to the power of 4 plus c. That would be our solution. So calculate the area of the region lying between the parabolas y equal x squared and x equal half 1/8 y squared. Now, to get the area, of course, you will have to integrate the region between the x values. So we need to find where these graphs intersect. So we have y equal x squared, and we have x equal 1/8 y squared. So we need to solve this simultaneously. We can use substitution. Now, x from here, we could use y squared. Now, y squared, if y equal x squared, then y squared would be x to the power of 4. Good. So I can replace this y squared with x to the power of 4. So therefore, x equal to 1/8. Sub this into that, right? So x equal to 1/8 y squared, but what is y squared? X to the power of 4. Good. And I guess we can times both sides by 8. So we have 8x equal x to the power of 4. We can just group everything on one side, right? So we end up with x to the power of 4, 0 equal x to the power of 4 minus 8x. If we factor out x, we get x cubed minus 8. Alright, we solve by factorization. So it means x equals 0 or x cubed minus 8 equals 0. So solving x cubed equal to 8, which means x equal to 2. So to get the area, we'll integrate the composite function of y between 0 and 2. So remember, these are the functions. So we have y equal x squared. We have y equal x squared, and then if I transpose for y here, let me just transpose for y. If I transpose for y here, this will become 8x equal to y squared, which means that y, from here, y will be the square root of 8x. Alright. So y equals the square root of 8x and x squared. So we combine those for the difference, since we find the region bounded by these two functions. So we integrate between root 8x and x squared between the x values 0 and 2. Alright. Yes, this will be between 0 and 2. So root 8, right? So root 8 and root x. Now root x, yeah, we can rewrite root x as x to the power of half, right? So both of them to the power of half, right? So which is minus x squared dx. Alright, let's integrate now. So integrate, so we have root 8. Integrate x to the power of half. We get x to the power of 3 over 2. Divide by 3 over 2, which is the same thing as multiplying by 2/3. Minus x cubed upon 3. And we're integrating between the limits 0 and 2. Alright, so in one we're going to form two brackets. In one bracket we plug substitute 0. Now if I plug in 0 in the second bracket, everything will be 0 there. And if I plug 2 in the in here, let's plug 2. So 2 to the power of 3 over, so what we'll have is 2 times root 8 times 2 to the power of 3 over 2 upon 3 minus 2 cubed, which is 8, so minus 8 upon 3. Just write it, make some space here. Let's see if we can fix this up now. Let's see if we can fix it up. Now notice the denominator will be 3, right? Since both of them, alright, so we are minus 8 out here. Let's see if we can fix up what's 2 root 8 times 2 to the power of 3 over 2. Now 2 to the power of 3 over 2. Alright, so now 2 to the power of 3 over 2 is same as root 8. So what you have is root 8 times root 8, which is 8. And then 2 times 8, which is 16. Alright, so all of this work out to be 16. And 16 minus 8, that's 8, so it's 8 over 3. And you're talking about area, so square 8 over 3 square units. That's our solution. The equation of the curve is given as, so we also find f prime, which is just the derivative. So f prime would be 12x cubed multiplied by the power subtract 1 minus 6x squared minus 12x plus 6. F double prime, you would take in the second derivative. So we differentiate the first derivative. we end up with, so the first derivative was that, so differentiate this, we get what? 36x squared minus 12x minus 12. So 36x squared minus 12x minus 12. So multiply by the power, subtract 1 from the power, right? Part 3, calculate the x-coordinates of the stationary points of the function and determine the nature of these stationary points. So stationary points occur, when f prime equal to 0, right? So f prime, remember what f prime was? 12x cubed minus 6x squared minus 12x plus 6 equated to 0, right? So to solve this, we can divide each term by 6. We can divide each term here by 6. Divide by 6, we get 2x cubed minus x squared minus 2x plus 1 is equal to 0. Now we can use the remainder, the factor theorem, to find the factors. So we can try 1. Let's try 1. Now f of 1 will be 2x. It will be 2 times 1 cube, which is 2, minus 1, minus 2, plus 1. What does that work out to be? 0. So therefore, x minus 1 is a factor. To get the other factors of this cubic equation here, we could use long division, or we could use synthetic division. I'm going to use synthetic division. Alright, synthetic division to get the other factors. Using synthetic division, alright, since x, remember f of 1 gave us 0, x minus 1 is a factor, so we put 1 out here. Just change the sign of this value here. Now we'll use the coefficients of the coefficients of the polynomial here, which was 2 minus 1 minus 2 and positive 1. Alright, so we bring down the first value, which is 2. So we say it takes its value, so 1 times 2, that's 2. Then we add negative 1 plus 2, that's positive 1. So we take this value outside, 1 times 1, that's 1. Then we add negative 2 to 1, we get negative 1. Then we use this value, 1 times minus 1, that's minus 1. So 1 plus negative 1, 0. Notice the last value here is always the remainder. The other values are the coefficients of the quadratic. Alright, so the other values, this would be 2x squared plus 1x minus 1. So those are the other factors. And can we factorize this? Let's try to factorize. So there we factorize. So if we equate both brackets to 0, x equal negative 1, and if we create the bracket to 0, x equal to half. And remember we had found x equal 1 as another solution. Because remember f of 1 gave us 0. So those are the x values of the stationary points. Let's get the y coordinates now. To get the y coordinates now, we sub these values into the original function. Remember what the original function was? It was the original function. Alright. 3x to the power of 4 minus 2x cubed minus 6x plus 6x squared plus x. We're going to plug the x values, each x value, and get the corresponding y values. So let's do the substitutions. Let me use 1 first. So when x equal to 1, y is what same thing we call f of x. Y is 3 minus 2 minus 6 plus 6, which is 1. When x equal minus 1, y is equal to 3 plus 2 Because remember, minus 1 cube is minus 1. Minus 1 times minus 2, that's positive 2. Minus 6. X is minus 1, minus 6 again. So this will be 5 minus 12. That's minus 7. Final value when x equal to half. The y value. So 3 times half to the power of 3 times half to the power of 4. Now half to the power of 4 is what? 1 over 16. So it's 3 over 16. Minus 2 over 8. 3 over 2 over 8. Minus 6 over 4. Plus what? 6 times half. 6 times half is positive 3, right? So this works out to be 1 and 7 16. Alright, so therefore stationary points are when x is 1, y is 1. When x is minus 1, y is minus 7. When x is half, y is 1 and 7 16. That's 1 and 7 16. That's an improper fraction. 16 plus 7, that's what? 23. So 23 upon 16. Now I just realized something here. Notice the question asks us for, let's go back up to the question. The question only asks us for calculate the x coordinates of the stationary point. So there was no need to find the y values. So we were asked to find only asked to find the x coordinates at the stationary points. So we could have stopped here when we find the x values. We could have stopped here. So this was could have stopped here because all I wanted were the x values. 1, negative 1, positive half. Now we were also find the nature of these stationary points. Alright, and to get the nature of these stationary points, we need to plug the x values into the second derivative. Remember what the second derivative was? Let's go back to the second derivative. The second derivative was, this was the second derivative. So we need to plug all the x values in the second derivative and see whether these values are greater than 0 or less than 0. So 36x squared minus 12x minus 12. Now we're going to plug 1. Let's plug 1. If we plug 1 into the second derivative, we get 36 minus 12 minus 12, which is 36 minus 24. That's what? 12, which is greater than 0. Therefore, minimum point at x equal to 1. Let's try when x is negative 1. Second derivative, try negative 1. Again, it's 36. Negative 12 times negative 1, that's positive 12. Minus 12, so that's 36, which is greater than 0. So, therefore, minimum at x equal minus 1. Let's try half. When x is half, we get 36 times half square. So it's 36 times quarter, which is 9. 12 times half, that's 6. Minus 12. So that's 9 minus 6. That's what? Minus 3. Minus 2. That's minus 15. Which is less than 0. When the second derivative is less than 0, it's a maximum. A maximum x equal positive half. Question 6. Determine whether or not the limit at f, the limit of f at x equal 1 exists. Let's test the right hand limit and the left hand limit. Right? So the left hand limit, which is evaluating the function, the limit of the function as x approaches 1 from the left, which is so less than, So we go 1 to the power of 4, which is 1 minus 1, upon 1 minus 1. Alright? Which is undefined. Undefined, right? Which means we could have to use factorization now and evaluate. So let me just rewrite the function. Limit x approaches 1. So I'm using this function here, x to the power of 4 minus 1 upon x minus 1. So we can always factorize. When it's undefined, we can always factorize. So if we factorize, we'll end up with x minus 1 upon x minus 1. So we're factoring difference of fourth power there. So x minus 1, the factor would be x cubed. I'm using the difference of quadruples here, a to the power of 4 minus b to the power of 4. This is equal to a minus b. And it's a very basic pattern here. A cubed plus a square b plus ab square plus b cubed. So in this factor, so x would be the a, represent a, b would represent 1, right? So a square b would be just x square. AB square, where a represent the x, right? So AB square will be just x. And b cube will be 1. Alright, so factor x minus 1 that. And if we substitute 1, we'll get 4. 1 plus 1 plus 1 plus 1, so 4. So the left hand limit is 4. The right hand limit now, use a value that's, we use domain for x is greater than 1, which is 4x. So the right hand limit we're using 4x, right? So limit of the function 4x would be 4. So notice that the right hand limit, so the limit of the function, which is the left hand limit, as you approach 1 from the left, is equal to the limit of the function as you approach 1 from the right. They are equal to each other. So therefore, limit exists. So limit of f exists at x equal to 1. Alright? So we can make that conclusion. Next, we were asked to determine whether the function is continuous at x equal to 1. And the answer would be no. And here's the reason why. Let's revisit the function again. Here's the reason why. Notice, when x equal to 1, f of 1 is equal to 2. So notice the reason is that f of 1 is equal to 2, which is not the same as the limit as x approaches 1. Alright? Not the same, because the limit of x as approaches 1 is 4. And 2 is not equal to 4, is it? Alright, so the answer there is no. Alright, so the parametric equation of a curve. So notice the function is dg, right? So dg on dx. Alright, so differentiate the y. So it's dy by dx. dy by d theta, sorry. Upon dx by d theta. Now dy by theta, differentiate the constant, you get 0, differentiate negative sine theta, that's negative cos theta, right? And dx by theta, differentiate 2 cos theta, that's negative 2 sine theta. And if you wish, I guess you could rewrite this as cot theta. Alright, cot theta upon 2, because cos over sine, that's cot, right? Upon 2. Or you can just leave it as it is, cos theta upon 2 sine theta, whichever. Determine the equation of the normal to the curve at the point. Alright, so to get the equation of the normal, you first have to get the equation of the tangent. So gradient of tangent. The gradient of tangent first, because remember dy by dx gives you gradient of tangent. So you'll recall that dy by dx was cos theta upon 2 sine theta. That was dy by dx, right? Now, so theta but notice, however, we do not have the value of theta, but we have information to find theta. Just remember the function here. X equal 2 cos theta and y equal 3 minus sine theta. Let's rewrite these. X equal 2 cos theta now x here is root 3, right? Which means that root 3 is equal to 2 cos theta. Which means that cos theta, divide both sides by 2. Cos theta is root 3 upon 2. Also, y was equal to 3 minus sine theta. And so y is 5 over 2 is equal to 3 minus sine theta. If I do some transposing here, sine theta is 3 minus 5 upon 2. So sine theta is half, which means that theta would be 30 degrees. Or you say pi upon 6, right? If you're going to convert it to pi radians. Here, same, if cos theta is root 3 upon 2, then theta is same 30 degrees, right? Or pi over 6. So we have theta. So now we can find dy by dx. So dy by dx is cos 30 upon sine 30. So it's cos 30 upon 2 sine 30. Now what's cos 30? Root 3 upon 2. So come down here, so cos 30. That's root 3 upon 2 divided by sine 30. That's half. So divide by 2 sine 30. So 2 sine 30. Now sine 30 is half. So 2 sine 30 will be 1. So it's just root 3 upon 2. So the gradient, and this, by the way, this is the gradient of the tangent. Root 3 upon 2. So therefore, gradient of the normal would be the negative reciprocal, right? Negative reciprocal of root 3 upon 2 would be minus 2 upon root 3. Which means that equation of tangent, equation of normal, is, so y minus y1 equal m into x minus x1. Alright? So is y, remember what the y values, y and x and y values were? Root 3 and 5 over 2. So minus 5 over 2 m, and the x value was root 3. And of course, you certainly can put this in a simpler form if asked. Right, let's see if we can do that. So y minus 5 upon 2, if I expand, I'll get negative 2x upon root 3 plus 2, right? Plus 2. Expand, we get positive 2, which means that y is equal to negative 2x upon root 3. So 2 plus 5 over 2. That's what now? 9 over 2. 9 over 2. So this is the equation of our normal. Final section, well, part C, second to last. The slope of a tangent to the curve g at the point xy is equal to the product, so the slope, which means that dy by dx, slope of a tangent, remember we get that by dy by dx, is equal to the product of the x coordinate and the reciprocal of the y coordinate, or the point of tangency. So formulate an appropriate differential equation and find the equation of the curve family. So this would be the differential equation, which means that y times dy is equal to x times dx. And we can integrate both sides, right? If we integrate both sides, y squared upon 2 is equal to x squared upon 2 plus c. So this would be the equation of the curve, right? Next, we're asked to determine the exact equation given that the curve passes through the point 1, 3. So remember what the equation was? Y squared upon 2 equal x squared upon 2 plus c. So substitute the point 1, 3, x is 1, y is 3. So we end up with 3 squared, that's 9 upon 2, equal 1 upon 2, 1 squared upon 2, so 1 upon 2 plus c, which means that 9 upon 2 minus 1 upon 2 is equal to c. So that's what 8 over 2, which is 4. Alright, so therefore, equation is y squared upon 2 equal x squared upon 2, sorry, plus c, so plus 4. And of course, and if you want to be neater, you can times each term by 2. You'll get y squared equal x squared plus 8. And you get that by times in each term by 2. I guess this will be way neater. So that's it. 2018 just completed.